The McDonnell Douglas, now Boeing, F-15E Strike Eagle is an American all-weather multi-role strike fighter, derived from the McDonnell Douglas F-15 Eagle. The F-15E was designed in the 1980s for long-range, high-speed interdiction, without relying on escort or electronic warfare aircraft. United States Air Force, USAF, F-15E Strike Eagles can be generally distinguished from other US Eagle variants by darker aircraft camouflage, conformal fuel tanks, CFTs, mounted along the engine intake ramps, although CFTs can also be mounted on earlier F-15 variants, and a tandem seat cockpit. The Strike Eagle has been deployed for military operations in Iraq, Afghanistan, Syria, and Libya, among others. During these operations, the strike fighter has carried out deep strikes against high-value targets in combat air patrols, and provided close air support for coalition troops. It has also been exported to several countries. The McDonnell Douglas F-15 Eagle was introduced by the USAF to replace its fleet of McDonnell Douglas F-4 Phantom IIs. Unlike the F-4, the F-15 was designed for the air superiority mission, with little consideration for a ground attack role. The F-15 Special Project Office opposed the idea of F-15s performing the interdiction mission, giving rise to the phrase, "not a pound for air to ground." In service, the F-15 has been a successful fighter, scoring over 100 aerial combat victories and 0 losses in air-to-air combat, as of 2007. Despite a lack of official interest, McDonnell Douglas quietly worked on an F-15-derived interdictor fighter. The company envisaged the aircraft as a replacement for the General Dynamics F-111 and the remaining F-4s, as well as to augment the existing F-15s. In 1978, the USAF initiated the Tactical All-Weather Requirements Study, which looked at McDonnell Douglas's proposal and other options, such as the purchase of further F-111FS. The study recommended the F-15E as the USAF's future strike platform. In 1979, McDonnell Douglas and Hughes began a close collaboration on the development of the F-15ES air-to-ground capabilities. To assist in the F-15ES development, McDonnell Douglas modified the second TF-15A prototype, AF serial number 71-0291, as a demonstrator. The aircraft, known as the Advanced Fighter Capability Demonstrator, first flew on 8 July 1980. It was previously used to test conformal fuel tanks, CFTs, initially designed for the F-15 under the designation Fast Pack, with FAST standing for Fuel and Sensor, Tactical. It was subsequently fitted with a PAVE-TAC laser designator targeting pod to allow the independent delivery of guided bombs. The demonstrator was displayed at the 1980 Farnborough Air Show. In March 1981, the USAF announced the Enhanced Tactical Fighter Program to procure a replacement for the F-111. The program was later renamed the Dual Role Fighter (DRF) competition. The concept envisioned an aircraft capable of launching deep air interdiction missions without requiring additional support by fighter escort or jamming. General Dynamics submitted the F-16XL, while McDonnell Douglas submitted the F-15E. The Panavia Tornado was also a candidate, but since the aircraft lacked a credible air superiority fighter capability, coupled with the fact that it was not American-made, it was not seriously considered. The DRF evaluation team, under the direction of Brigadier General Ronald W. Yates, ran from 1981 through 30 April 1983, during which the F-15E logged more than 200 flights, demonstrated takeoff weight of more than 75,000 pounds, and validated 16 different weapons carrying configurations. McDonnell Douglas, to assist 71-0291 in the evaluation, added to the program other F-15s, designated 78-0468, 80-0055, and 81-0063. The single-engined F-16XL was a promising design, which with its radically redesigned crank delta wing, greatly boosted performance. If selected, the single and two-seat versions were to be designated F-16E and F-16F, respectively. On 24 February 1984, the USAF chose the F-15E. Key factors in the decision were the F-15ES lowered development costs, compared to the F-16XL, US $270 million versus US $470 million, a belief that the F-15E had future growth potential, and possessing twin-engine redundancy. The USAF was initially expected to procure 400 aircraft, a figure later revised to 392. Construction of the first 3 F-15s started in July 1985. The first of these, 86-0183, made its maiden flight on 11 December 1986. Piloted by Gary Jennings, the aircraft reached a maximum speed of Mach 0.9 and an altitude of 40,000 feet during the 75-minute flight. This aircraft had the full F-15E avionics suite and the redesigned front fuselage, but not the aft fuselage and the common engine bay. The latter was featured on 86-0184, while 86-0185 incorporated all the changes of the F-15E from the F-15. On 31 March 1987, the first officially completed F-15E made its first flight. The first production F-15E was delivered to the 405th Tactical Training Wing, Luke Air Force Base, Arizona, in April 1988. Production continued into the 2000s with 236 produced for the USAF through 2001. The F-15EX Deep Strike mission is a radical departure from the original intent of the F-15 since it was designed as an air superiority fighter under the mantra not a pound for air-to-ground. The basic airframe, however, proved versatile enough to produce a very capable strike fighter. The F-15E, while designed for ground attack, retains the air-to-air lethality of the F-15 and can defend itself against enemy aircraft. The F-15E prototype was a modification of the two-seat F-15B. Despite its origins, it includes significant structural changes as well as more powerful engines. The aft fuselage was designed to incorporate the more powerful engines with advanced engine base structures and doors, which incorporate superplastic forming and diffusion bonding technologies. The backseat is equipped for a Weapons Systems Officer, WSO, pronounced WISO, to work the air-to-ground avionics via multiple screens. These view the radar, electronic warfare, or thermographic cameras, monitor aircraft or weapons status and possible threats, select targets, and use an electronic moving map to navigate. Two hand controls are used to select new displays and to refine targeting information. Displays can be moved from one screen to another using a menu of display options. Unlike previous two-place jets, e.g. the F-14 Tomcat and AV variants of the F-4, is backseat omitted flying controls. The F-15EX backseat is equipped with its own stick and throttle, so the WSO can take over flying, albeit with reduced visibility. For extended range, the F-15E is fitted with two conformal fuel tanks, CFTs, that hug the fuselage to produce lower drag than conventional underwing underbelly drop tanks. They carry 750 US gallons of fuel, and house 6 weapons hardpoints in 2 rows of 3 in tandem. Unlike conventional drop tanks, CFTs cannot be jettisoned, thus increased range is a trade-off for increased drag and weight compared to a clean configuration. The Tactical Electronic Warfare System, TEWS, integrates all countermeasures on the craft. Radar warning receivers, radar jammer, radar, and chaff flare dispensers are all tied to the TEWS to provide comprehensive defense against detection and tracking. This system includes an externally mounted ALQ-131 ECM pod which is carried on the centerline pylon when required. The MIDS Fighter Data Link Terminal, produced by BAE Systems, improves situational awareness and communications capabilities via the Link 16 data link. The APG-70 radar allows crews to detect ground targets from longer ranges. One feature is that, after a sweep of a target area, the crew may freeze the air-to-ground map then switch to air-to-air mode to scan for aerial threats. During air-to-surface weapon delivery, the pilot is capable of detecting, targeting, and engaging air-to-air targets, while the WSO designates ground targets. The APG-70 is to be replaced by the NAPG-8 which began flight tests in January 2010 with initial operational capability expected in 2014. Its inertial navigation system uses a laser gyroscope to continuously monitor the aircraft's position and provide information to the central computer and other systems, including a digital moving map in both cockpits. The low-altitude navigation and targeting infrared for night lantern system is mounted externally under the engine intakes. It allows the aircraft to fly at low altitudes, at night, and in any weather conditions, to attack ground targets with a variety of precision-guided and unguided weapons. The lantern system gives the F-15E exceptional accuracy in weapons delivery day or night, and in poor weather, and consists of 2 pods attached to the exterior of the aircraft. At night, the video picture from the lantern can be projected on the head-up display, HUD, producing an infrared image of the ground. The ANAQ-13 navigation pod contains a terrain-following radar which allows the pilot to safely fly at a very low altitude following cues displayed on a HUD. It also can be coupled to the autopilot to provide hands-off terrain-following capability. This pod also contains a forward-looking infrared system which is projected on the HUD, typically used during nighttime or low-visibility operations. The nav pod is installed beneath the right engine intake. The targeting pod contains a laser designator and a tracking system that mark an enemy for destruction as far away as 10 miles. Once tracking has started, targeting information is automatically handed off to infrared homing air-to-surface missiles or laser-guided bombs.